So lesson 10 of Unit 1 actually doesn't have any new lesson notes. So I'm going to go right into the examples for this lesson. So let's take a look at this first set of examples here. Define the sequence W so that W of n is the number of white squares in stage n. So W stands for white squares in stage n. Is sequence W arithmetic, geometric, or neither? So let's first count the number of white squares in each shape. So for stage 0, if my starting term is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 white squares to start with. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 white squares for term 1. And then term 2, stage 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So my first 3 terms are 10, 14, and 18. This is definitely an arithmetic sequence because my pattern is to add 4 each time. 10 plus 4 is 14, plus 4 is 18. So number 2, write the closed form for sequence W. So I'm going to do that one down here. So closed form is what we did in the last lesson, lessons 8 and 9. And if you forgot, look back into your lesson notes from lessons 8 and 9. But this right here, if you forgot, is the formula for closed form of an arithmetic sequence. So f of n equals f of 0 plus n minus d times n. So in this case, remember f of 0 is our starting term. So our starting term in this case is going to be 10. So f of 0 is 10. This is an increasing sequence, so we're going to use plus. D is our common difference. What is our common difference? Well, we already said that was adding 4. So plus 4 times n. So number 2, write the closed form for sequence W. That's going to be 10 plus 4 times n. Okay, so that's number 2. Number 3, we're going to do the same thing, except now we're going to write the recursive form. So the recursive form, that goes back to a prior lesson before lessons 8 and 9. So remember, the recursive form has 2 parts to it. So the first part is your starting term, your f of 0. So f of 0 in this case is going to be 10. And then the second part of the recursive is how we're going to get a new term based on the previous term. Well, we've already said we're adding 4 each time. So to get a new term, we're going to take the previous term and we're going to add 4 to it. So I'm just going to write that using formal mathematical notation. So this is going to be f of n, that's my new term, equals f of n minus 1, that's my previous term, plus 4. So f of 0 equals 10, and f of n equals f of n minus 1 plus 4. So both of these things here, that is the answer to number 3. Remember, I mentioned this in the recursive lesson. If you were to just write that part, you would be partially correct, but you would not be fully correct. You have to write both parts of the recursive definition. I can't tell you how to get a term from the previous term if I don't tell you where to start. Okay? It's impossible to do, which is why you need both parts, the f of 0 and the f of n. So that's our first set of examples. Let's take a look at the second group of examples here. So in this one, define sequence D such that D of n is the number of dots in stage n. So let's do the same thing that we did in the previous set of examples. So we start off with 1, 2 dots in stage 0. Then we have 1, 2, 3, 4 dots in stage 1. And then we have 1, 2, 3, 4, 5, 6, 7, 8 dots in stage 2. So we go from 2 to 4 to 8. Those are my first 3 terms of the sequence. So to answer question 4, is sequence D arithmetic, geometric, or neither? This is pretty clearly going to be a geometric sequence because I'm multiplying by 2. I'm doubling each time. So number 4, it is a geometric sequence. Number 5, write the closed form for sequence D. Again, if you forgot the formula for closed for geometric sequences, look back at your lesson notes from the last video, lessons 8 and 9. So here is your formula. So remember, it's f of n equals f of 0 times r to the power of n. So my starting term, my f of 0 in this case is 2. So this is going to be a 2. My r is my common ratio. What am I multiplying by each time? I'm multiplying by 2. So in this case, not only is f of 0 equal to 2, but r is also equal to 2 because I'm multiplying by 2 each time. So my closed form is 2 times 2 to the power of n. So that's your answer to number 5. Number 6, write the recursive form for sequence D. So remember with recursive, we got to write the 2 parts. So we already know my f of 0, my starting term is 2. All right, that's my starting term. And then to get each new term, so f of n, I'm going to take the previous term, f of n minus 1, and I'm going to multiply the previous term by what? In this case, I'm going to multiply it by 2. So f of 0 equals 2, and f of n equals f of n minus 1 times 2. So new term equals previous term times 2. So this that I'm circling right now, that is your answer to number 6, and that is it for lesson 10.